Ever struggled with backaches while trying to balance a dripping shirt on a bamboo pole? Thought about getting a tumble dryer but scared it will burn a hole in your wallet? Don't worry, the Dry Guys got you! Presenting the Dryinator, a smart and modern solution to indoor drying. Standing at a comfortable height of 1 meter, our rack helps prevent posture related strain, all while using minimal energy to dry your clothes effectively.
When the total mass detected by our two load sensors exceeds 50 grams, a countdown of 5 seconds will start. Afterwards, 5 fans will be switched on, with the bottom 4 fans starting to pulse. This causes the shirt to oscillate, pushing away humid air, allowing for faster drying. This also helps the bottom hem to dry faster.
Hours later.
Our final energy consumption, 840 watt hours. As compared to a conventional tumble dryer that is 4,000 to 5,000 watt hours, our Dryinator consumes around 80% less energy. Today we'll be unboxing this new centrifugal fan. I got the ASMR. Comes with 3 wires and a fan.
Live reporting at Mount Menanti, where we recently found a volcanologist who died from gas poisoning.
This has to stop! prototype only. Yeah, exactly. Minimum viable product. Right.
If you want to release it in the market, you have to improve it further.
Yeah.
Invent more parties to improve it.
From an aeroplane, you know I leave with a body for metal space. My heart, my God, can't stop my heart. Saying I got trouble in my eyes. I'm just looking for another good time. My heart, my God, can't stop my heart. Yeah, are you ready, girls? Yeah, are you ready now? Yeah, can't stop my heart, give it a start. Can't stop my heart, hope it never stops. Somewhere over the rainbow, way up high, and the dreams that you dream of once in a lullaby. Oh, somewhere over the rainbow, bluebirds fly.
Then this one is following the knob from the ukulele. So to make it, to strengthen the reinforcement, right, to strengthen the shaft, to strengthen the structural integrity and to reduce the stress, right, we filleted it, instead of like sharp edges, we filleted it like this.
Wake up where the clouds are far behind. Flaming drops high above the chimney top, that's where you find me. Somewhere over the rainbow, bluebirds fly.
Isaac Malaysia, some of then Brandon holiday after that.
Thank you.
Find me, oh, somewhere over the rainbow, way up high.
It works.
Yay! This is a video.
Having trouble staying awake while driving? This is a common issue that many drivers face, but hidden beneath are deadly consequences. But we've designed a solution. Introducing Wake Up, our biosignal monitoring wearable device to prevent drowsy driving. Commercial products like Speeder use cameras to track eyelid closure as a sign of drowsiness. However, this image-based approach fails to function effectively under low-light conditions, highlighting variability during night driving, precisely when drowsiness is most likely to occur. Alternatively, our device employs an innovative EEG technology which monitors the electrical activity of the brain in real time. This allows for more accurate detection and even prediction of drowsiness without relying on facial features. Our device quantifies fatigue using two parameters, blink rate and the relative band power of brain waves. When the user's blink rate or band power crosses a threshold set by our classifier, the device detects it as a sign of fatigue and instantly triggers a noise alert through the headphones.
Wake up, wake up, wake up.
To make the device more wearable, we embedded the wiring and circuit boards into the cap, fitting some inside the lining and hiding the rest in a concealed false top. Hence, our device is easy to wear. When the driver begins her journey with an alert mind, no noise is emitted, but the Raspberry Pi continually monitors the driver's state of alertness. Once the driver starts to feel fatigued, the system will trigger a noise alert to wake the driver up.
Wake up.
This is Asthma Ally, an innovatively engineered non-invasive asthma detection device with the potential to reshape the lives of many asthmatic patients all over the globe. In this video, find out more about how this product has come to be.
What are some ergonomical considerations you had when making the design?
When designing the product, some ergonomic considerations we've taken is ensuring that the product is lightweight, breathable, and elastic as people will be wearing them 24/7. Comfort is therefore one of our main considerations, and thus we use elastic bands and buckles to maximize comfort while still being very secure. The product also has smooth edges so that the plastic portions do not cut into the user's skin. As you can see, it is smooth here. This was done with multiple iterations to maximize comfort with full functionality.
What was the most difficult part of putting together the product?
The most difficult part was the wiring. Since this is just a DIY project and we were still at the prototype stage, we didn't get to create a PCB which was much better for tiny wearables. So I had to squeeze a bunch of wiring inside and make sure that the solder connections did not break off, which took like 3-4 tries. How does your machine learning predict asthma attacks?
So our body sends signals out all of the time, and the wrist wearable as well as the chest wearable collect all these signals like your breathing rate, your coughing patterns, wheezing, and sends it into this algorithm. And what happens is that this algorithm starts to recognize the small changes that occur when an asthma attack is about to happen. So it can predict when the next one will be happening when certain things like maybe your blood saturation levels drop or your wheezing goes up. It will know that it's time to go to the doctor.
So, how did the app come to be?
Java is the most suitable language for coding an app. But as someone with almost no coding background and definitely no Java background, it is a very hard and tedious app to learn. So instead of trying to learn Java from scratch, I learned what I needed to code what is necessary for my groupmates. And I feel like this has resulted in a sleek and elegant app that does all that is required without complicating the user interface.
We now interrupt you with a commercial break.
Does the lingering smell of cigarette smoke suffocate you? Do you feel irritated when secondhand smoke drifts into your home from a neighbor's window? This is a daily struggle for many Singaporeans. Yet, smoking at home is simply impossible to ban.
Unfortunately, besides the fact that such legislation could be highly intrusive, there are significant practical challenges in enforcement that limit effectiveness.
Our simple and powerful prototype aims to create a more breathable environment for all. By using targeted suction and an advanced filtration system, it captures harmful smoke at the source, removing both toxins and odor before they spread. Let's now take a closer look at each component. Our device comprises 8 fans arranged in parallel configuration. They provide strong targeted suction to pull secondhand smoke across our filtration unit. The first filter that we incorporated is the HEPA filter. HEPA filters contain a dense network of randomly arranged fibers, allowing them to effectively capture airborne particles, including tar, particulate matter, and nicotine droplets from secondhand smoke. Our device also contains 2 activated carbon filters. Volatile organic compounds, including formaldehyde, benzene, and toluene, are adsorbed to pores of the carbon material and effectively removed from secondhand smoke. Our last filter is 3D printed and contains zeolites impregnated with potassium permanganate. Potassium permanganate is a strong oxidizing agent that decomposes volatile organic compounds to non-toxic substances, such as carbon dioxide and water. Our nozzles were designed to maximize the suction cross-section. 2 different designs are shown, with simulation performed to analyze airflow through them. Both nozzles performed decently well. Another key component we have is the air sensors and displays that provide users with real-time concentrations of VOCs and particulate matter. Sensors were strategically positioned at both the inlet and outlet of our device. These sensors also provided the team with meaningful data for analysis. As seen from the two charts, VOC concentration in outlet air is much lower after passing through our filters. To conclude, Breathe Easy can provide effective air purification and will reduce disturbance to residents living near smokers.
Is this you? Imagine that you're sleeping peacefully on your back, when you decide to switch to your side. Do you find yourself slipping your arm under your pillow to make it just a little higher? Do you suffer from neck pain because of poor sleep posture? If so, we have the solution for you. Introducing the Cloud. The Cloud is a smart pillow that intelligently detects your sleeping position and automatically adjusts its height according to personalized presets. Neck and lower head support is provided by 3 aluminum bars whose movements are enabled by 2 stepper actuators on each end. Thin film pressure sensors provide feedback to help determine your sleeping position. And finally, the airbag supports your upper head, driven by 2 air pumps with opposing airflow. First, under manual calibration mode, calibrate the height of the support bars and airbag based on your individual comfort level using the buttons provided. Next, complete pressure calibration for each preset and watch the Cloud do its magic. The pillow continually monitors for large sustained changes in pressure, which indicates when you have switched your sleeping position. The pillow provides automatic height adjustment based on the detected sleeping position, ensuring optimal head and neck support throughout the night without the need for you to intervene. Experience the Cloud today to discover the wonders of personalized sleep and restful nights.
Let's start with fast flow rates and maybe 4,000 milliliters per hour. When I confirm the flow rate, the system starts priming, then I just zero the reading. So for now we get 34 as the reading, which is still close to the 33.33 reading that we want. So after resetting from the fast flow rate, let us demonstrate the low flow rate, 52 into 649. We will select 100. Again, the model will prime. I'll just 0 and then wait for 30 seconds. So it has ended. We get from 0.83. It can be sometimes 0.82 to 0.85. The reading can fluctuate, but for now it has ended at 0.83, and now we get the exact flow rate that we want for the slow flow rates.
So we are testing the PID controller with the gear pump assembly assembled, and let's open this up. Okay, so we are setting it around 150 ml per hour, and we're uploading the code now. And yeah, like previously, the PID performance is quite good, and it reaches steady state relatively quickly. So let's turn these two off. The blue line is the PWM, so it's the power output to the motor. And you can see that it is going very oscillating or going up and down of the target, which is good because when you average it out, it will become much like it will become to the target flow rate that you want. And looking at the gear, the movement of the gears is also quite smooth, so that's also very good.
Bees, going about the day doing nature's important task, pollination. But today, the harmonious buzzing fades. Habitat losses, pesticides, climate change, all of which threatens these tiny creatures. Without bees, 85% of all cultivated crops are affected, and 1/3 of our global food supply depletes. If we can't stop the bees from disappearing, what shall we do? We, the stinglets, refuse to sit back and watch disaster unravel. After months of hard work, we created the Stinglets, a small and agile pollinator drone with a big mission, with a goal to supplement the role of bees in the pollination of crops and safeguarding our crop yields. The Stinglet comprises 3 key components: a quadcopter drone, a pollinator extension, and a pollinator brush. For demonstration purposes, we will be using our second prototype, a Mavic 3 DJI drone equipped with our pollinator extension and brush, as compared to our self-made drone could provide more stable hover and flight. Mimicking a bee, the stinglet is manually controlled to fly toward a flower. It then proceeds to extend its pollinator brush. The extension uses a rack and pinion mechanism, which is 3D printed. This creates a safe distance between the drone's propeller and the downwash that could damage the flower. The drone's analog camera aids in navigation, which shows up on a monitor, allowing the precise aiming of the pollinator directly towards the flower. The brush rotates 360 degrees to dislodge and pick up any pollens. Making its way to the next flower, it performs the same extension and spinning motion, transferring the pollen grains and completing the pollination. Visualization of the pollen transfer is evident, and our sunflowers have begun showing first signs of successful pollination, which involves the shedding of petals in preparation for seeds to form in the future. A transmitter controls the flight of the drone, while a website controls the extension and rotation of the pollinator. With greater improvements, the stinglet will achieve more. Bees may be in danger, but with the stinglet, hope still flies.